Welcome to the Explainer. Today, we're diving into a core concept in JavaScript that honestly might just change how you think about your code. We're talking about the secret life of functions. So here's the plan. We're going to start with a pretty surprising question. Are functions really objects? Then we'll look at the properties they come with right out of the box, see how we can add our own, and then explore a really neat pattern called the named function expression. And finally, we'll wrap it all up by talking about why any of this is such a game changer for your code. All right, let's just jump right in. The first thing we need to do is kind of challenge what most of us think a function actually is and what it can really do. Now, I know this might sound a little weird. We're used to thinking of functions as these self-contained blocks of instructions. But what if they could hold data, almost like they have their own little backpack of information? Well, it turns out they can. And it's all because of a fundamental secret in JavaScript. Okay, so here's the big reveal. In JavaScript, functions aren't just code. They're actually a special kind of object. Think of them as action objects. This means, yeah, you can call them to make them do stuff, but you can also treat them like any other object. You can add properties to them, remove properties, pass them around by reference, the whole shebang. So since functions are objects, it gets even more interesting. They come pre-packaged with their own set of super useful built-in properties that we can access right away. First up, we have the name property. And what's so cool about this is how smart JavaScript is. It doesn't matter if you're writing a classic function declaration or an anonymous function that you assign to a variable or even a method inside an object. The JavaScript engine is smart enough to figure out the function's name just from the context. Next, there's the length property. This one is super simple, but also incredibly useful. It just tells you how many parameters a function officially expects to get based on how you wrote it. And this is a perfect illustration of a key rule. Let's say we have a function defined like this: many a, b, ... more. Well, its length is going to be 2. Why? Because those rest parameters, the ones collected by the 3 dots, they don't count towards the length property. It only counts the explicitly named parameters that come before. Okay, so this is where it starts to get really practical. Since functions are objects, we're not just stuck with the built-in properties. Oh no, we can add our own. This is such a great pattern. You could, for example, attach a counter property directly to a function just to keep track of how many times it's been called. The state, that call count, lives right there on the function object itself. It keeps your code so clean and organized. Now, you might be thinking, hey, couldn't I just do this with a closure? And you're totally right, you could. But there's a really important difference. A variable that's inside a closure is private. You can't access it from the outside. A function property, on the other hand, is public. Anyone can read it or even change it. So which one you choose really just depends on whether you want that state to be private or public. This brings us to a really powerful, super practical application of everything we've talked about so far, the named function expression, or NFE for short. This whole pattern was created to solve a very specific and honestly a very tricky problem that can pop up when you're working with recursive functions, functions that call themselves. So imagine you've got a function that needs to call itself to get its job done. What happens if the variable that's holding that function gets changed somewhere else in your code? Or worse, what if it gets set to null? Well, that internal recursive call is suddenly going to fail. Check this out. It's a perfect example. We define a function, say hi, and inside it calls say hi. Simple enough. Then we assign it to a new variable called welcome. But watch what happens when we set the original say hi to null. When we try to call welcome, it tries to run that internal say hi guest call, but the outer say hi variable doesn't exist anymore. It's null, and the whole thing just crashes. And this is where the NFE comes in to save the day. By giving the function an internal name right when we define it, we create this super reliable reference that the function can always use to call itself, no matter what happens to the variable on the outside. So let's fix that broken code. See the change? Let say hi equals function func, parentheses. That name, func, is the special part. It's only visible inside the function itself. So now the internal call is func guest. And look, even when we set the outer say hi variable to null, our welcome function still works perfectly because its internal reference, func, is totally safe and sound. So what's the big picture here? After all this, why should you care that functions are actually objects in JavaScript? Well, it matters because this idea lets us write code that's cleaner, more powerful, and way more organized. It means our functions can carry our own data. It means we can look inside them with .name and .length. We can build a rock-solid recursive functions with NFEs. And this isn't just an academic idea. Huge libraries like jQuery and Lodash use this exact principle. They have a main function object, like the $sign or the underscore, and they attach all their other helper methods to it as properties. It keeps the global space squeaky clean. So, you see, understanding that functions are objects isn't just a fun piece of trivia. It's a legitimate tool in your toolbox. It opens up brand new ways to structure your apps and to solve tricky problems in a really elegant way. So now that you know their secret, the only question is, how are you going to use it?